What do you think the future looks like? Are you thinking about the future in 10, 20, 50 years? Well, we physicists tend to think about the very distant future, in billions of years. This idea that we had about it changed drastically in the 90s after an unexpected discovery. Galaxies are flying away from each other faster and faster with time. This led to the question, what is causing this accelerated expansion of the universe, and can it ever stop? One popular theory states that this expansion is caused by a strange energy that we call dark energy. Unfortunately, there is a lot that we don't know about dark energy, and hence questions about the evolution of the universe remain unsolved. In my research, I studied dark energy by analyzing systems of double Einstein rings. These are systems that are compounded by a heavy galaxy and two additional galaxies located behind the first one. The presence of the heavy galaxy curves the light coming out of the two other galaxies, and this can be perceived as pieces of two rings in the sky. This approach for studying dark energy couldn't be performed 10 years ago because we didn't have telescopes that could see deep enough in the sky to detect these systems. But now we have them. In addition, for these systems, we can define a variable that depends on the radii of the rings, and this variable is more sensitive to the dark energy nature than other methods. In consequence, by performing a statistical analysis of this variable, we can be more conclusive about the nature of dark energy. To start this analysis, first we need to find double Einstein rings. The plan is to perform a search on the data gathered by the Dark Energy Survey, a census of hundreds of millions of galaxies. Unfortunately, we're looking for a needle in a haystack. Out of 36 million images, we expect 10 or 20 to have the presence of these systems. However, this tedious task can be performed by a machine. To do this, we need to create simulations of these systems and use them to train the machine to detect an image with a double Einstein ring. Then, we can use real images as input for the machine to find these systems. Hopefully, we'll find enough systems to perform a statistical analysis and understand more about the nature of dark energy and, in consequence, about the future of the universe.